Hello, everybody. Okay, this is good. So last night we were trying to chase down this bug and we were looking at things and we were looking at other, well, okay, maybe this is good. We were getting inconsistency or confusion in regard to narrowing down the problem. So I woke up this morning, I was like, look, before we do any of this LLVM stuff, I want to make this, oh, okay, this is obviously wrong. It's always going to fire because J equals I. That's kind of stupid. Let's see if it still goes. Okay, it's still going. So we can see if that's legit catching the problem. But the idea is we're catching the problem right before this happens. And the thing is this data gets set up way before, right? So now once we're calling this and we're catching the problem, we can then move this the call earlier in time, right? Um, until we move it to exactly the time at which the problem happened. Okay, that one didn't do set off. Interesting. Okay, still didn't get set. Let's. The breakpoints might be messing with something. I don't like it when the breakpoints are messing with something, but it could be. But all these really old. We don't want these. Okay, so it's literally we're running it dash dash. Okay, now it's not happening. Okay. So it's happening 1 out of n runs. So we just got to keep going, hopefully, and we'll catch it. There we go. There we go. Okay. So patch is lambda, and this is probably the string literal, right? It is. Okay, good. Good. Okay. So what's good about this is we've caught this problem, assuming that this is actually wrong. So one of the many uncertainties floating around last night was like, does this mean something different than what I think it means and whatever? But I think it's okay. And so we've caught this on our own terms before any of the LLVN backend nonsense has to happen. And so that's good because we've isolated out any question about whether the conversion to what LLVM wants is causing the problem, right? If we detect the problem before that. So assuming this is good, we can just move this forward in time. So for example, I can call this function literally after every time that we add something to this data segment, right? Um, so for example, now this might take longer to run because it's a stupid n squared loop. I could put this in a hash table or something, but hash tables in C++ are annoying enough. This is like if we had self-hosted the compiler, it would be really joyous and easy to use a hash table to do stuff, but in C++ it's not. Okay, so all right. Literal segment, array literal into global data, struct literal into global data. Who calls this? Anyway, so it is a struct literal. It's getting called from outside the file, but this is a struct literal, and we can literally do what we do here. And we can do it here. Now, this may still not exactly, in fact, okay, anytime you do this, you do it before and you do it after. And the reason you do it before is because, well, the reason you're doing it after is to say, like, okay, did it happen in this code that I just ran? But the reason you do it before is to say, did it happen somewhere that I'm not detecting yet? All right, we missed. We hit. Okay. We're emitting a macro expansion. Okay. Okay. This, I'm just curious about what macro is this? It's in basic line 154. Well, okay, hold on. Basic what? I forget where. String literal for fun. God. String builder. 154? Assert. What? Oh, because there's an empty string literal? But that should get deduplicate. Okay, wait. Okay. No, there's a struct literal. Oh, but okay. So again, we're hitting the before. So it did happen like before this. But wait, what is the struct literal? What are you even talking about? So this is line 98. What is the struct? Oh, it's got to be the caller location struct. It's got to be the caller location struct. Okay. That's fine. That's fine, actually. Um, you know what I kind of want to do? So one of the things I'm doing here is just saying, like, let's try to get the call site so we can nail this down. It must be instruct literal. It was an instruct literal. Okay. But the thing that I'm realizing is we have this add remote pointer patch. It's only called within this file. And we're doing this file name and line number thing. And I would really like it if I knew the line. So here's what I'm going to do. So once, instead of this, we're going to go line number, right? And anywhere we do this, we're going to do this. And then we're going to be able to look when our assertion fires. And we're going to be able to say it was from this line number. Now, if this were our programming language instead of C++, we could do this automatically without editing the call sites. But this language that we're using right this second sucks. Oh, we got to do this from the debugger anyway. Got to run a few times. Okay. So, patch line number 1215, other line number 858. See the magic there? 1215 is procedure patch dot target memory. Oh God, this is about stack traces. And this thing isn't checking. Create stack trace node linear allocation. Okay. Anyway, this is sus. This could be wrong in some way, or the other thing could be wrong in some way. And I'm going to put the fucking space there where it should be. Okay. Pointer base. Okay, nothing obviously wrong here. Oh, I just edited the file, so Visual Studio is going to freak out. 1215. Right, so 858 is the other one. So that's just literally adding a string literal, but this is probably called from a struct literal or something. Okay, so the only way the only way that we should be able to get overlapping address patches like this is if we're putting them into the same memory range for some reason. Why the fuck? Who is doing this to my code? All right. So we could try to detect that because that would be the ultimate source of the problem. the thing is, when we do this, let me see if we have an allocation up here. So we have a destination pointer and a base address. We could just go nuts and save that data as well, but that's actually not necessarily helpful because we're like many recursive levels down in a thing. I made the mistake of glancing at chat. Big mistake. Yes. Okay. So there are at least two possibilities for what's happening. One is that for some reason we are trying to overlap the memory of two literals. And that would, of course, be bad. And the other thing that could be happening is that the literals are in the right place, but the relocation info is getting messed up due to some of these complexities that we have. For example, the thing we were looking at last night about deduplicating literals. And part of the problem is this thing is low level enough that we don't have all of the context we would like to be able to look at to debug the problem from where we are looking. Okay, but since we know that the line numbers here, we can call sanity segment from those. In fact, you know what? We can just do the nuclear option here, right? So let's not do this. Let's not do this. We're going to do in add remote pointer patch, instead of this stuff that we had, we're going to say immediately after adding the patch. Oh, we have a sanity patch as well. I didn't even know that. I don't know where that is or what that does. Let's look at that really fast. Nothing. It does nothing. Okay, great. So, well, what could it do? Type definition, procedure. Yeah, those aren't things that we're worried about right now. So here we're going to go if relocation info is equal. Oh, we don't have interp. Fuck. Oh, yeah, we do. Global data interp literals segment. Is that where it is? There it is. Relocation info, yeah. If it's that, then we're going to do this. That should, in principle, be the nuclear option that catches every single one. Oh, it's on global data to begin with. Lol. 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 Okay. Okay. Interesting. We caught one that we haven't necessarily seen. Are the expressions the same? Doubt it. So this is weird. Okay. The assert may not be right. And if the assert's not right, let's check that. Let's check what where pointer lives means. Because if the assert's not right, that might mean the LLVM code is just wrong somehow. So the question is, does where pointer lives, does it reference the base of the segment, in which case this assert would be right? Or does it reference the target memory, in which it would be wrong? I don't think it can reference the target memory. I think it has to reference the base of the segment. But we'll see. Okay, so first of all, though, I want to know... Okay, this is... This is weird. What? Let's look at these lines for a second. 1242 again. That was this string literal thing for a procedure stack trace node. 866 is a string literal, just vanilla. And is that where we are? Where are we right now? We are, yeah, 866. Visual Studio thinks it's 870, but that's because Visual Studio is stupid. So this is not good. But we're looking for something that's not good, so that's good, I guess. So now why... We don't have the stack for the other one, but we have the stack for this. So we can look at how did we get here and does it make sense, right? So base address here is 0. Okay, that's weird. It's already weird that we've already put a bunch of stuff into the literal segment, and then we're supposedly putting stuff into base address 0. Why are we putting a struct literal into base address 0 when we've been filling out the segment already somewhat? Right? There were, how many patches were there? There were 22. So what's going on there? Oh, this is our dummy base address. Oh, shit. Okay. Okay. Guys, this code is just, we keep ending up back here. So the reason the base address is 0 is because we're not doing the real patches yet. Because we're about to do the relocation or the deduplication check, but the deduplication check won't fire right now anyway. Okay. Like, in principle, these relocations should go into a temporary thing that we would throw away if we deduplicate the literal. We don't do that in part because we could just pop them off, I guess. But this is making it annoying right now. It's so the thing is, I tried to catch the thing at the site, and the problem is I can't catch the thing at the site because we changed the addresses later down here. So I would have to catch it down here, which means, but this is only for struct literals. So this is very annoying. And maybe at this point, we just try to figure out how to change the code, right? So that it doesn't work this way. Guys, holy fuck. Guys, what? Why don't you use these techniques that are brand new and don't really work and are only used by people who can't make software that actually works? Why don't you use those? Oh my God. Anyway, all right. So we're going to heat up a little breakfast while we think about this. So we keep coming back to this code. I don't like this code. This code makes me kind of angry. One thing that we could do, so literal deduplication is an optimization, right? We could turn that off and see if the problem goes away. And then that would tell us that our literal deduplication is buggy. But the problem is it's not just deduplication, it's non-weird, it's pre-weirdness. Maybe we can at least just give it the real base address. Because we know the allocation. Why am I giving it a dummy base address? Anyway. That's a good question. Wait, where is the linear? I guess because we don't allocate till down here. That's the problem. I hate this. I hate it. I hate it. I hate it. I hate it. No, this is the same bug from yesterday. Uh, we are hunting it down even more effectively. Um, it's just this code. This code is gnarly in a way that I don't like, and it would improve, even if we're ignoring this bug for a second, it would improve the compiler just to make this code less gnarly. Because I don't like what it does, because what it does makes debugging more difficult, and you don't want that, right? You don't want, it makes debugging more difficult for two reasons. One, the reason we're having right now, which is that we can't check for patch validity when we add the frickin' patch, okay, which is kind of crazy. But then two, it's also confusing because this is just extra complexity that you have to remember even happens. And we didn't remember that last night. It took time to like observe the behavior and figure out that this is what's happening and stuff. So, um, okay. What could we do to fix this? Well, one option is instead of putting this in the actual relocations array, we could have a dummy relocations array and then just copy them over. That is better than what we do now. Maybe, probably. We would be calling add remote pointer patch once for the dummy version, and then once for, the adjusted version. This would like happen twice. This that does nothing would happen. Literally, all that happens is this really puts it in this array. So I think I like that, but I'm gonna go heat up some internet meme Wendy's chili, and then wait. I think we ate all of that last night. I'll check, um, and then maybe we'll come back and do that because that would at least help with debugging somewhat because the technique I'm doing now would actually work. All right, back in a second. Does anyone have any questions that are not about you know what topics? Are the patch data in an array? Yes. They're in an array by value. Which is honestly a little bit weird. So here you see that we're passing a pointer to a patch, and then we're adding by dereferencing the pointer. So we're doing a value copy here. Why are we even doing that? I don't remember. Like, why do we have a patch? I think it's just usually we allocate this on the stack. And then we wanted this abstraction that everybody goes through precisely so that we could debug, right? Could you reserve, e.g., 1,000 elements to avoid it being reallocated and copied? Yeah, we probably could do that. I didn't think of that last night, but it would probably have to be more than 1,000. I mean, this is a small program, so maybe 1,000 is fine. But yes, the idea in principle would work, yes. Because it's not like there's a trillion of these arrays. There's literally one place that we know where it is where this problem is happening. That said, the reason we wanted that data breakpoint was just to get those line numbers that we have since got by other means. So like we don't need to do that now. But if I had thought to do it last night, then that would have been a good thing to do. Yesterday, I put an exclamation point in front of a false. Did I delete after the test? No, but that's because that was the reproduction case for our bug. And in the process of investigating the bug, we found things that are wrong regardless of whether that is set, which is good because it turns it less from a Heisenbug into more of an actual bug. It's like, oh, there's an actual bug that happens all the time, or not even all the time, but a lot. And you only see it when that value is set that way. But now that we're asserting and stuff, we're seeing it more reliably. All right, let me grab the food. Are there any devices in my home network that I'd like to be connected via cable, but lack Ethernet jacks and have to use Wi-Fi instead? No, I don't want a home network. I don't want devices at home on the internet, except for my computers, of which there are way too many, but those are the only things that I want on the internet. I don't want my refrigerator on the internet. I don't want my TV on the internet. I don't want the toilet on the internet. I don't whatever you think should be on the internet. I don't want it on the internet. Any other questions? So the thing we're thinking about while I ask for other questions is just, besides putting the patches in a temporary place, is there anything better that we can do? What is this? Dude, Visual Studio is so bad at everything now. Go to definition. Okay, we're 2 lines off. In a header file, like what? Okay, this is unnecessary complication. What happened to the VOD from last night? I just didn't publish it. Um, I don't know. I just felt like we were just sitting there looking at this bug. It didn't seem super productive. I mean, we did investigate the bug and talk about the bug, but we didn't solve the bug. I don't know. Okay. I don't have a better idea right now than to change how this is working. I mean, there are 2 refactorings we could do. We could clean it up so that the temporary relocations are not going into the array, which I like. And we could try to clean it up so that we could toggle deduplication on struct literals here. But the problem, that's non-trivial the way it's set up. We'll see. We'll see if it becomes less non-trivial after we do this other thing. Okay. We're going to go here. We're going to have a thing called dummy relocations. All right. I'm going to delete this. Going to go down here. And we're going to not assign this so that we don't use this. Where does this actually get used? So we're going to not do that. We're going to assert dummy relocations dot um, oh, you know, this might not be true actually. I was going to assert that it's empty. Oh, okay. So there's a complication here already, which is this function could get called recursively. And what happens if it gets called recursively? See, in theory, okay, so having actually the thing I just did is maybe not a good idea. Okay, you know what? If we want this to be clean, we do it locally and we just leak the frickin' memory, is what we do. All right, that's what we're going to do. And then we can figure out what to do about that. Because we need this to be correct. Okay, so we're going to do dummy relocations. Oh, yeah. Dude, if this gets called recursively, this code's going to fuck up. I understand. Okay. So here's the deal. Let's look at this. We do a struct literal, we do some relocations, we come out here and we remap them, right? We go from the start of whatever, however many relocations there were before we got to this struct, right? And then we go to the end of the array. And we remap. Okay. Well, what's at the end of the array? Well, if we didn't recurse, it's our relocations. But if we did recurse, it'll include relocations on substructs, which themselves could be struct literals. Right? Which will get double remapped in that case. And double remapping is bad news bears. Assuming that we can in fact recurse. Let's fix this typo. Assuming that we can in fact recurse from here, which, like, obviously you can. Obviously you can. Okay. So I think that is a likely candidate for the problem we are seeing. If it is not the problem we are seeing, it is probably still a problem and we just happen to not be seeing it. So yeah, let's fix this crap right here. Okay, so dummy relocations. We're going to put this into dummy relocations. And we don't have an old state. Fuck you. Okay. And then This is going to be like that. Okay, so then we do the allocation. And then here, oh, this is remote pointer patches. All right. Okay. Writing struct literals can create locations outside the struct literal's memory if it causes us to write out a struct. Okay, this is actually kind of bad. Um, I guess, but okay. And then we're gonna go add remote pointer patch. Do we have this? Where's our relocation info? Relocations, star patch, and line. Cannot convert from array of oh, yeah. We only need one of these. Okay, 205. Okay, add remote pointer patch. 263. Oh, it wants a pointer to a patch. Right, we dereference inside. All right. 268. Okay, relocation. Okay. This may still be wrong, but okay. Um, I think this is okay. So what we just did, we weren't worried about the compile time pointers. I think that's what. Let's see. Oh, maybe. Bro, Visual Studio sucks so bad. Like, why are you down here? Go here. Um, what is it? Context default value records. Okay. This is very strange. We may be uncovering. This is like really not where I expected to be looking. So we're running a modify directive. Okay, so we're running a modify directive. We've changed the context since the last time, which is a thing that could happen. Um, oh, this is the first time that we've ever run a run directive, I guess. Um, so we're making the context record. The context record is a struct literal. Okay, so one of the things we did down here, which is suspect, is this. But I don't know if that has to do with what we're looking at right this second. I don't know why this wants relocations. Note context default value. Context default value records. I mean, I guess that's oh yeah, okay. No, I know what this is for. I know what this is for. Okay, well, actually, it's relevant. It's relevant. So, because here, we're looking at the context default value records. There are two of them. Okay. Which one are we looking at? One. It's just not initialized completely, right? So the relocation info. Oh, okay. Okay. So my dummy relocations are on the stack. All right. This probably is why the bug was a bug. And this might be important enough that I have to think about it offline. All of this has to do with compiler features that were done in the last year. Okay, so let me give you guys a rundown. In order to allow more flexibility when your modules want to modify the context by adding things, like it used to be that the context had to be frozen before you could ever run any code. So we would disallow add context after a certain time. But what that meant was if you were doing stuff that was mostly meant to run at compile time, like plugins, stuff that analyzes your program and dynamically determines what to load, which is the power of compile time execution, is that you're more like a scripting language and you want to do more of that stuff, right? The problem was you couldn't ever use add context because you had already started running. And that was kind of ass. So I went to this system where the context could expand after the fact. Now, if the context expands and you've already, for example, compiled a literal for the context, then you kind of need to go modify that to make sure it has the right value for whatever's been added. That's what these context default value records are. These are like, oh, these are the places where we emitted the default value of the context already, so that if you change them, we can do something about it. All right. Here's the problem. This works fine, including all the stuff that I just did. If things are simple. But in this program that we are compiling, we're using the thread pool. The thread pool has a data structure that has a context value as a member of the data structure because it's the default context that we want to start threads with. That value is a context, and we are compiling it. We're generating the code for that, and then we're going back later and we're like, oh, let's change it. All right. Which I would like to not have to do it all, but supporting this level of this feature seems to require this. The thing that I just did about, we got to go here. The thing that I just did about doing these dummy relocations looks fine if you just look at this code, because you're like, look, there's dummy relocations, copy the struct literal, and then we'll come down here, we'll move the relocations out of the dummy relocations. The problem is this thing looks like, oh, we're using the real relocations here. Okay. Um, what I was about to say is actually slightly wrong, but okay. For some reason, I thought it was because I declared the dummy relocations on the stack, and it doesn't. We need to figure this part out. But the point is, we're storing in permanent global storage um, this context default value, which has a relocation info on it, which if this was on the stack, it's like not valid anymore. Why would it be on the stack? Well, it would be if we had a struct that contained a struct that had that was a context, right? Okay. Now, that's not actually quite right because we get it off the segment. So the worst that would happen is more like I'm trying to get back to this. Um just so that this value is live. Okay, this is weird actually because this should just be literally off of a data segment. And we don't delete data segments. But anyway, this is actually pretty complicated what's happening, and it's not surprising if there's a problem at all. This is the kind of code that you try to avoid if you can help it. But the problem with making a programming language with a lot of really useful features is some of those features get gnarly when you're trying to implement them. Okay. Are you able to step through the compilation? What do you think we've been doing this whole time? What do you think this literally is? Who is showing up in chat these days? All right. I think Choco Tuesday is a large language model. That's what I think. All right. Bug is more complex than I had thought. Well, I knew it was complex because I didn't understand what the hell was going on in the beginning. Um, Now I kind of get it. There's still some details I don't totally get, but I would say it is due to code that I wish were a lot simpler than it is. Do you know what this is over here? This is the stack of the compiler of the things that we're doing. These are the things that we're doing. All right. Oh my God. All right. Um, I'm gonna ignore chat for a while, guys. I'm gonna ignore chat for a while. Okay. What What do we do about this? Okay, so I don't 100% understand exactly what happened here because this shouldn't be okay. Okay, even if this were on the stack and we just copied the value and then it went unlive, our integer values would still be correct. Just our memory would go away, right? The fact that our integer values are not correct. In fact, are they fifis? What are they? They're cc's. Well, that does okay. CC means you returned something from off the stack. That's what that means. For those of us who've been in the trenches for a while. But I don't understand how that happened. But it sure looks like we returned a pointer to a relocation info off the stack and then copied it, which is weird. Um, so we literally get the literal segment, literally, right? This alignment doesn't get used until way later. We'll move that. Okay. We'll take this off the top here. We don't need that now. We don't need the one on the bottom. Neither did we take that out. We don't need that one. Okay, so okay. So quite conspicuously, we put this dummy relocations on the stack. And we're passing that down. So in theory, what I was thinking is like, oh, we recurse back into here and we don't know it's on the stack, but it is. And then we assign it. But we don't assign it to that. We don't assign it to anything that comes in as a parameter. We get the literal segment directly. And what we pass to add remote pointer patch, or no, to note context default value is this thing, which is not on the stack. So I don't know how that's getting messed up now. And well, okay, does anyone else call this note context default value? Oh, someone else does. Uh, copy struct. Wait. Okay, this is both in our same function, I think, right? So this is line 692. Oh, no, it's not. Okay. This is allocate and copy struct literal into global data. This is copy struct default value into global data. And this is going to put our dummy relocations on there. Okay. That is annoying. Okay, but that's what's happening here. So all this code, this is probably part of why I didn't do this originally. I was thinking like, oh, I didn't originally make it a local copy because I didn't want to waste memory on the stack or make it a little slower or something. No, I did it because this code really wants it to be the real relocation info. That said, I don't know. I don't know why we're passing that. I also feel like we're just kind of doing this twice in some cases because of this, right? So let's look at this. Um, we had two here. Are these like the same? Right? So context default value records 0. Shut up. Oh, we're going to do all these things to make programming smarter. Context default value records 1. We're going to make programming so smart. This is going to be smart. All right. Um these are actually not the same. Okay. Interesting. Okay, so at least we know why this is happening. At least we know why this is complicated. I don't like any of this at all. So I kind of think at this point, rather than try to fix this really squirrely bug, I think the question is, how do we simplify this code to make it better, regardless of this bug? And then if the bug gets fixed with that, that's great. If the bug doesn't get fixed with that, we use the bug to help us call attention to something in the compiler that is too hard to understand. That's actually been, so there was a time some years ago, you start making a compiler like this, you're building it out, the features get added and things get more complicated every time you add a feature, right? And there's like this explosion of both usefulness of the language, but also just like feature complexity. And at some point, you realize, oh, we got to make this more robust. And you start working on it. And you're like, all of a sudden, this code is really, really hard to understand, right? And what I learned during that time that was very useful was like, look, if you ever feel this feeling of like, oh, I'm scared in some way of this particular code, um, almost always there's not really a good reason for that. It's like not super required. It's just that at the time that you wrote that code, you didn't have a better idea how to do it, but then later you may have a better idea how to do it, right? So, um, in this particular okay, here the irony, the Alanis Morissette irony of this whole thing is the code is structured this way with the temporary dummy relocations and all that just so that we can emit the literal and then check for deduplication, right? I'm trying to find the code again. Where was it? Here. So, right, we're emitting the literal so that we can check for deduplication, but we punted on deduplication if there are patches anyway. So like what I think we should do is just emit the literal and if we decide to deduplicate it because there are no patches, then we can just like back up the state of the data segment or revert the state of the data segment so that that allocation isn't there anymore. Um, that actually might be more complicated than I would like as well, because, again, this could be recursive and all that, right? Um, However, given how gnarly this is turning out, it's probably better than this. Maybe we would have to look at it, but yeah, because it's only if there's no patches, there really can't be. Yeah. Okay. So here we go. I think we figured out the bug. The bug is, in theory, that this will double remap when you have nested struct literals. There might actually be a way to test that. Like we could make a hash table somewhere where every time we remap, we store the value. But I think that's what's going on, and that's why some things are ending up in the wrong place. Um, my solution that we could just try to fix the code to not double remap. I don't exactly know how we would do that because it's annoying because you would have to determine. We could put more information in the patch about like what's the I don't know. Maybe that wouldn't work. We could do something here, but my preference is just to delete this code. I don't like this code. I don't want it here. Um, I don't want dummy relocations. I don't want any of this. I want the real relocations. So I'm going to spend a little more time. It's almost time for me to wake up, take a shower, go out, have some fun today. But I'm going to be thinking about this today because there are a few details. There's that context record initializer thing and all that. But this code, like this is one of these weird things where the code doesn't look that bad. Like if you're just scrolling through the code and you see this, you're like, okay, there's just some simple function calls an if statement. It's not that big of a deal, right? Whatever. But actually, it's just made the code a lot harder to understand and debug the dynamics of what's happening here, right? The statics of this, the amount of code and how simple the code looks are fine. It's just actually not good, like dynamically. So, yeah, this is the goal. All right. So, um, maybe we'll do a stream later today where we actually do this. Maybe not. If I do it, I might do it just in a coffee shop, with my mind wandering and not having to read comments about why aren't you using an LLM. Um, if I do that, maybe we'll do a review of what we actually did later on. Either way, I think we've got this one. So we just need to take off and nuke the site from orbit, really. How deep in the list of the priorities is removing the inline assembler from the compiler and giving the users the ability to write inline assemblers in user space? I mean, that's one of the things where if I had a magic wand, it would have happened already. But there's just a limit on how much I can do, right? Um, so that one's just sort of waiting till we have time to do it. It's also just waiting. I think in principle, the design of how do you externalize the assembler so that people can write things in user space and interface, I think we've done enough of that kind of thing in this language that for the most part, it's not that hard and it's figured out. However, there is a little bit of squirrely stuff like, you need to tell the assembler for any given platform, if you want the power to be able to interface with, like, I'm not just writing assembly in the middle of a function, but I can use the parameters to that function and the local variables and stuff. You need a way to tell the external assembler about those things and where they are, like what register are they in and whatever, right? Um, th- that does require, like, you just have to decide how that works on literally every platform, right? And that's really kind of annoying. At least though, you could be more explicit about it. So, like, if we're going to pin a value to a register so that you can see it when you write the assembly, we can at least, like, you pass that value as part of the compile this assembly. And it's very explicit then, like, oh, this thing is taking up a pin for the duration of this assembly, um, which is probably better than what we're doing now, actually, because we don't ever unpin things. And in a big procedure, you need to unpin things or else you run out of registers. Why did I stop reading that geometry book? I literally posted why in the reply to that tweet. I posted 3 paragraphs about why. Okay. Claude would smash this out in less than $200. You are delusional, sir. Spoken like someone who's never written a compiler. Oh my God. The Pavel Grinfield book. What book is that? Let's see. Pavel Grinfield. That's not what we were looking for. Neither of these is the right book. You think he was joking? Oh, the Claude thing. Well, guys, the thing you can't joke about that because there's people in my chat bombarding me with this crap. Like, at some point, I just need to clear my information environment, and like whether it's a joke or not doesn't actually matter. Like, what matters is, can I read the chat without going insane or not? Amazon shows my, well, it shows my zip code. I guess it would show my address if I actually order it. Super joints. Introduction to tensor analysis. Maybe they just don't have it. Let's see. Introduction to tensor analysis. Okay. Cool. We'll order that. We're not going to click on it right now and dox ourselves. I mean, did I search for the guy's name and it just didn't come up? Like, maybe they're vibe coding Amazon search now. I don't know. Am I considering selling my gaming company if I can continue to work for it? Why would I do that? I've worked very, very hard to be able to control what we make because I want to make things that other people wouldn't make. And you're saying, would you, in return for money, give all that up and just be working a job? No, no. I mean, I could see selling a company if you didn't have to work for it anymore. But then in my case, That would probably also involve, like, any decent sale price you get from selling a game company is going to involve selling the IPs of the games that you made, and I don't really want to do that. It was one letter off. Okay. It can help you not have to lay off people. Well, but can it though? Like, the entire game industry is still undergoing massive layoffs right now. Sony just shut down a studio 2 days ago and laid everybody. Like, I'm not sure that it does that. But what if you could not control the things you made? I never thought about that. Yeah, chat is really weird today. All right. Let's see if there's someone else doing programming that we can send you over to. What's high level Minecraft dev? Okay, that's a new. Is this some kind of certification like MSEE? I worry about testosterone because there's more and more furries every time we look. Um, okay. Firm catering firm. What does that even mean? Just horsing around, making a horse. Is it like horse jam today? Okay. Well, well, well. Programming all day. Oh, this looks like assembly. What's going on here? Okay, he's got a non-programmer keyboard, but he's making Snake in assembly. So that's pretty good. Is this fake? Is this like an AI generated stream? What programmer would use one of these gimmick keyboards? It's a ghost stream. I don't even know what that means. This is in Russian.
И 5 минус 3.5. И здесь он rotated на,
Okay.
на 300, ну, на 180 развернуть. То есть это...
Let's not subject you all to that. Not that there's anything wrong with that. Just most of my chat is English speaking. I don't know, guys. I mean, we could go to this dude again. We rated him a while back. I really don't see much else going on. I mean, probably something here is good, but it's just hard to tell. You know? Hard to tell. All right. Thanks, everybody. And we'll see you later.